Good morning to all of my students. Myself, Mr. Dibyendu Mondal, Assistant Professor of Mechanical Engineering Department of Greater Kolkata College of Engineering and Management under JIS Group. In this pandemic situation, I am delivering my lecture through online mode and my video is uploaded in YouTube. Good morning. Previous class we have already studied the power transmission of shaft. Power transmission of shaft, that is equal to power is equal to T into omega. Okay, Kn is equal to rpm of the shaft, T is equal to mean torque transmitted in Newton meter, or omega, that is the angular speed of the shaft. So power is equal to 2 pi n T star by 60. So that is equal to omega into T, or T times omega. Now in a hollow circular shaft of outer and inner diameter of 20 centimeter and 10 centimeter respectively, the shear stress is not to exceed 40 Newton per millimeter square. Find the maximum torque which the shaft can safely transmit. In a hollow circular shaft, the outer and inner diameter of 20 centimeter and 10 centimeter respectively, the shear stress is not exceed 40 Newton per millimeter square. Find the maximum torque which the shaft can safely transmit. So the outer diameter D0 equal to 200 millimeter. Inner diameter D1 is equal to 100 millimeter. Maximum shear stress tau is equal to 40 Newton per millimeter square. T is equal to maximum torque transmitted by the shaft. So T equal to pi by 16 tau d0 to the power 4 minus di to the power 4 by d0. So that is equal to pi by 16 into 40, 200 to the power 4 minus 100 to the power 4 divided by 200. Pi by 16 into 40, so 16 into 10 to the power 8 minus 1 into 10 to the power 8 divided by 200. So 58904860 Newton millimeter. Two shafts of the same material and same length are subjected to the same torque. If the first shaft of a solid circular section and the second shaft is of hollow circular section, whose internal diameter is 2/3 of the outside diameter and the maximum shear stress is developed in each shaft. Given two shafts of the same material and same length transmit the same torque and develops the same maximum stress. Capital T is equal to torque transmitted by each shaft. Tau is equal to maximum shear stress developed in each shaft. Capital D is equal to outer diameter of solid shaft. D0, that is the outer diameter of the hollow shaft. Di, that is the inner diameter of the hollow shaft. D suffix I, inner diameter of the hollow shaft. Okay, that is equal to 2/3 of D0. Ws, that is the weight of the solid shaft. Wh, weight of the hollow shaft. Length of each shaft L, and W is equal to weight density of the material of each shaft. So torque transmitted by the solid shaft is given by the equation T is equal to pi by 16 tau into d cube. So torque transmitted by the hollow shaft is given by the equation 16.6 T equal to pi by 16 tau d0 to the power 4 minus di to the power 4 divided by d0. So pi by 16 into tau d0 to the power 4 minus 2/3 of d0 whole to the power 4 divided by d0. So d0 to the power 4 minus 16 by 81 d0 to the power 4 by d0. So that is equal to pi by 16 tau into 65 d0 to the power 4 81 d0. Pi by 16 into tau into 65 d0 cube divided by 81. As torque transmitted by the solid and hollow shaft are equal, hence equating equation 1 and 2, pi by 16 tau into d cube equal to pi by 16 65 by 81 d0 cube. Cancelling pi by 16 tau both sides, d cube is equal to 65 by 81 d0 cube. So d equal to 65 by 81 d0 cube whole to the power 1/3. So that is equal to 65 by 81 whole to the power 1/3. So d0 equal to 0.929 d0. Okay, capital D equal to 0.929 d0. Now weight of the solid shaft Ws, that is equal to weight density into volume of the solid shaft. Now weight of the solid shaft Ws, so that is W into area of cross section into length. Okay, W into pi by 4 into d square multiplied by length L. Weight of the hollow shaft, that is equal to WH, W into cross sectional area of the cross section of the hollow shaft into length. W into pi by 4 d0 square minus di square into L. So that is equal to W into pi by 4 d0 square minus 2/3 of d0 square multiplied by L. So W, that is equal to W into pi by 4 d0 square minus 4 by 9 d0 square into L. So that is equal to W into pi by 4 into 5 by 9 d0 square into L. So dividing equation Ws, that is equal to, very important problem, Ws equal to W into pi by 4 d square L divided by W into pi by 4 5 by 9 d0 square into L. So that is equal to 9 d square divided by 5 d0 square. So 9 by 5 into 0.929 d0 square by d0 square. So 9 by 5 into 0.929 square into d0 square by d0 square. So that is equal to 1.55 by 1. So weight of the solid shaft divided by weight of the hollow shaft, that is equal to 1.55 by 1. A solid circular shaft and a hollow circular shaft whose inside diameter is 3 by 4 of the outside diameter are of the same material of equal length and are required to transmit a given torque. Compare the weight of these two shafts if the maximum shear stress developed in the two shafts are equal. Diameter of the hollow shaft, that is equal to 3 by 4 diameter at outside. 3 by 4 d0, that is equal to 0.75 into d0. L is equal to length of both shaft, equal length. T is equal to torque transmitted by each shaft. Tau is equal to maximum shear stress developed in each shaft. D is equal to diameter of the solid shaft. Omega A, Ws, that is equal to weight of the solid shaft, and Wh, weight of the hollow shaft. Torque transmitted by a solid shaft is given by the equation T is equal to pi by 16 tau into d cube. Okay. তাহলে পাই বাই 16 টাউ ইন্টু ডি কিউব। তাহলে টর্ক ট্রান্সমিটেড বাই এ হলো শ্যাফট ইজ গিভেন টি ইজ ইকাল টু পাই বাই 16 ইন্টু টাউ ইন্টু ডি জিরো টু দি পাওয়ার 4 মাইনাস ডিআই টু দি পাওয়ার 4 by d zero. So that is equal to pi by 16 into tau into d0 to the power 4 minus 0.75 d0 to the power 4 by d0. So pi by 16 into tau d0 to the power 4 by d0, 1 minus 0.75 whole to the power 4. Pi by 16 into tau d0 cube into 1 minus 0.3164. So that is equal to pi by 16 into tau into d0 cube into 0.6836. But torque transmitted by solid shaft, so that is equal to torque transmitted by hollow shaft. Hence equating the equation pi by 16 into tau into d cube, so that is equal to pi by 16 into tau d0 cube into 0.6836. d cube is equal to 0.6836 d0 cube. d is equal to 0.6836 1/3 whole to the power 1/3 into d0. d is equal to 0.8809 d0. Now weight of the solid shaft, weight that is equal to rho into g into volume of the solid shaft. Rho into g into pi by 4 d square into L. So weight of the hollow shaft WA is that is equal to rho into g volume of the hollow shaft. So rho into g pi by 4 d0 square minus di square into L. So rho into g pi by 4 d0 square minus 0.75 d0 square into L. Rho into g into pi by 4 d0 square minus 0.5625 d0 square into L. So rho g pi by 4 d0 square 1 minus 0.5625 into L. So therefore that is equal to rho g pi by 4 d0 square into 0.4375 L. Dividing the equation 4 and 5, Ws is equal by Wh, rho into g pi by 4 d square L divided by rho into g pi by 4 d0 square into 0.4375 into L. So d square equal to 0.4375 d0 square. Therefore 0.8809 d0 square d0 whole square divided by 0.4375 d0 square, so that is equal to 0.776 d0 square 0.4375 d0 square, so that is equal to 1.7737. Another one problem, a hollow circular shaft 20 millimeter thickness transmit 300 kilowatt power output at 200 rpm. Determine the external diameter of the shaft. If the shear strain due to torsion is not to exceed 0.00896, take the modulus of rigidity equal to 0.8 into 10 to the power 5 Newton per millimeter square. Okay. Now torsion, speed is equal to 200 rpm, phi is equal to 0.0086, okay, 0.0086, c equal to 0.8 into 10 to the power 5 Newton per millimeter square, d0 is equal to external diameter of the shaft, di is equal to internal diameter of the shaft, d0 is equal to di plus 2t, so di plus 2 into 20, di equal to d0 minus 40. So P is equal to 2 pi nt by 60 or t into omega. That is equal to 2 pi into 200 into t by 60. So capital T is equal to this one, 30,000 into 60 divided by 2 pi into 200. So 1432.3.9 Newton meter. So that is equal to 1432.3.9 into 1000 Newton millimeter. So 1432.3900 Newton millimeter. C is equal to shear stress by shear strain. C, modulus of rigidity, shear stress by shear strain, 0.8 into 10 to the power 5 is equal to shear stress by 0.008986. So shear stress tau equal to 0.8 into 10 to the power 5 into 0.00086. So 68.8 Newton per millimeter square. T is equal to pi by 16 into tau d0 whole to the power 4 minus di whole to the power 4 divided by d0. So 1432.3900, that is equal to pi by 16 into 68.8 d0 to the power 4 minus di to the power 4 by d0. So 1432.3900 into 16 into d0 divided by pi into 68.6. That is equal to d0 to the power 4 minus di to the power 4. So 10,60334.6 d0, that is equal to d0 whole to the power 4 minus di whole to the power 4, equal to d0 square plus di square, d0 square minus di square. Substituting the value of di from equation 1 into the above equation, actually 10,60334.6 d0 equal to d0 square plus d0 minus 40 whole square, d0 square minus d0 minus 40 whole square. So after calculating d0 square plus d0 square plus 1600 minus 80 d0 and d0 square minus d0 square minus 1600 plus d0. Okay. So 2 d0 square plus 1600 minus 80 d0, 80 d0 minus 1600, that is equal to 2 d0 square plus 800 minus 40 d0. So 80 d0 minus 20. So 160 d0 square minus 40 d0 plus 800 d0 minus 20. So that is equal 10,60334.6 d0 by 160. So that is equal to d0 square minus 40 d0 plus 800 d0 minus 20. So 6627 d0 equal to d0 cube minus 20 d0 square minus 40 d0 square plus 800 d0 plus 800 d0 minus 1600. So d0 cube minus 60 d0 square minus 5027 d0 minus 16000. Now by trial and error let d0 equal to 100 millimeter. So LHS this one is equal to minus 118700. Okay. Let d0 is equal to 110. LHS is equal to 36030. Okay. Let d0 equal to 108 millimeter. Substituting the value LHS equal to 1194. Actually, if you calculate 108 cube minus 6 into 108 square minus 5027 into 108, after calculation you will get 1194. Okay. Last, if you like my video, you have to subscribe. Okay, thank you.